Hey guys! Have you ever asked yourself why water sprays out of the shower head the way it does and doesn't just trickle out? No? Well, even so, there's still an answer, so stay tuned. Let's start by looking at a water pipe like this. On the other side, the pipe is wide and has a certain cross-section, which we'll call A1. At the other end, the pipe is narrow and has a smaller cross-section. We'll write that as A2. Now, let's let some water flow through it. It comes in through the large opening and flows at a certain speed to the right towards the narrower opening. So for each unit of time, the same amount of water enters at the left as flows out on the right. That is, what goes in the front comes out the back and in the same amount of time. The dark part on the left shows the amount of water that flows through the wide cross-section in a given time. The same amount of water flows through the smaller section of pipe on the right in the same amount of time. And to calculate the amount of water, that is the volume, we simply multiply the cross-section A1 by the velocity of the water V1 and the time the water takes to flow through the wide part of the pipe. You can also easily imagine that geometrically, as if you were calculating the volume of a cuboid. That would be the base A1 by the height V1. Keep in mind that V1 is the speed that the water needs to flow through the thick part of the pipe. Now, we can also do the same for the volume V2. That is, in the time it flows at a velocity V2 through the cross-section A2. And because we've just said that exactly, the same amount of water must come out the end as flows in, we can now make an equation for the whole thing. So delta V1 is the same as delta V2. That is, we can just cancel it out. We know already that A2 is smaller than A1. And because both sides have to yield the same value, the velocity in the narrower pipe has to be higher than the velocity in the wider pipe. So that means that the water in the narrower part of the pipe flows faster than in the wider part. It's all very logical, really. The same amount of water has to flow through the narrower pipe in the same amount of time, so it's got to flow faster. And that's just what the continuity principle states. That is to say, it describes the relationship between the flow rate and the cross-section of the pipe. This means that the smaller the cross-section of the pipe becomes, the higher the velocity of the fluid flowing through the pipe will be. But there's one small matter we've got to consider. This equation only applies to incompressible fluids. As a technical term, fluid means gases and liquids. And incompressible simply means that the density of the fluid is the same everywhere, whether in the wider part of the pipe or in the narrower part. This applies to the vast majority of liquids. For example, water is more or less an incompressible fluid, so we can apply this simple equation to it. If the term density doesn't mean that much to you yet, just take a look at our video on it. But what do we do when we aren't dealing with an incompressible fluid? Very simple. Then we include a ρ for density in the continuity equation. ρ1 is the density of the fluid in the wide part of the pipe, and in the same way, ρ2 stands for the density in the narrow part. And now we have the general continuity equation. Okay, let's get back to our shower. Imagine that the wide water pipe that the water has to flow through to get to the shower head is inside the wall, and the shower head itself only has small holes that the water can flow through. The total cross-section of all the holes is still less than the cross-section of the water pipe, so the cross-section of the water pipe is reduced. That means that water sprays much faster out of the shower head, and that's how you get the jet of water that you all know. A garden hose would be another example. If we let water flow through it and hold a thumb over the opening, the cross-section is also reduced here and the water sprays out much faster. So let's summarize all the important bits again. The continuity equation describes the relationship between the flow rate and the cross-section of the pipe. If the pipe gets smaller, then the flow rate increases, so that the same amount of fluid flows through the pipe in a certain amount of time. Put simply, what goes comes back out. If you want to find out more about fluids, just check out our playlist on fluid dynamics.